All right, and this is part 2 of the final tips and tricks for the SAT math section from changlearning.com. And we're continuing now with the next topic, other coordinate planes problems. These problems include reading the XY coordinate plane and finding distances, rules of lines, slope, parabolas, and graphing circles. So I've only picked 2 examples here that are level 4 and 5 problems. The first one here is presented as a line and circle. So the first equation in the system is a circle, and the second is the linear equation. And it reads, what is the value of x times y to the solution to the system of equations below? So a little tricky because you can't just plug in the x and y from the 4 choices and place them into the equation. But we do know, if we're familiar with the circle formula, that the center is at 0, 0. And the radius is 5. And we know this because the square root of 25 is 5. So knowing that the radius is 5 makes sense if we look at the picture here. So I'll draw a few arrows here in red inside the circle in the 4 cardinal directions. So the center's at 0, 0. If I go up 5 units, we're at the edge of the circle at the point 0, 5. Also, if we go to the right at 3 o'clock in the circle here, at the point 5, 0. Down here below at 6 o'clock, it's at the point 0, negative 5. And also here at 9 o'clock, we're working with the same circle with radius 5. So a point on the circumference is negative 5, 0. If you look at the second equation, you should see the ratio has something to do with 3 and 4 and 5. So what you should cleverly think is, the shortcut here is, think of the 3, 4, 5 right triangle. So what I'll do is I'll draw in some possible points where the 2 can intersect if I draw a 3, 4, 5 right triangle. So I guess if we're going around counterclockwise, the first one would be this right triangle. So I'll draw them up and upside down so you can see it. I'm trying and shade it in or just stripe it. But this triangle has legs 3 and 4, and the hypotenuse is 5. Everyone see that? The height of the triangle here, I'll label here on the right side, is 4 units going up, and it's 3 units here. And that 5 there is subtracting, so I'm just going to white it out on the screen so you can just see the 3 and 4. So that's one possible location where they can intersect, because if you plug into the equation, we literally get 3 squared plus 4 squared equals 5 squared, or 25. So that would be one point that's legitimately on the red circle. Well, that coordinate is negative 3, 4. Continuing with this idea, there's another possible point where they can, if I flip the triangle, if I have like that triangle tool that's 3, 4, 5 on each side, well, I can also go 4 units to the left and up 3 units. And then there's this triangle. So here's another point within the circle that's another 3, 4, 5 right triangle. So now the base is 4 and the height is 3. But by the laws of math here of the Pythagorean Theorem, I'll stripe this triangle down here. 3 squared plus 4 squared, again, is the hypotenuse of 5, which is the radius of the triangle. So the coordinates here, because the circle is centered at 0, 0, it's going to be minus 4 for x and 3 for y. So we really have 2 points. These are the 2 points that I'm considering, because I look and I see, oh, there's some 3s and 4s there. And sure enough, if we plug in, that one looks like it's directly at the tangent line. I'll put a gold star on it. That one looks like there's a gap between them, so it doesn't look like that's the intersection. It looks like -4, 3 is better. And sure enough, if we plug them into both formulas, we'll have, well, x, y as -4, 3. We have -4 squared, which is 16, plus 9 equals 25. So it's good for equation number 1. And then for equation number 2, we have 3 times y. Well, y is 3, so that's 9. 3 times 3 is 9. And then -4 times -4 is plus 16. And that's also equal to 25. So that is the solution for 3. And they said, well, what's the value of x times y? That's the extra step, -4 times 3, which is -12. And the correct answer is B. So the shortcut here is to be familiar with Pythagorean triples, that this is really, the circle has contained within it right triangles if you go around like a carousel. Here I'll highlight in green with these green dots. The locations of the 3, 4 shaped rectangle, we have 8 more points that we can map on the circumference of the circle. And this is called, in math, it's called the 12-point circle. We have the 4 directions in space: east, north, south, east, and west. And then if you have any single Pythagorean triangle, you can place 2 in each quadrant for a total of 8 more points. And you can draw a nice circle. If before computers, you could draw a nice circle with these 12 points, just using your knowledge of right triangles. I'll draw it in here. It looks like one of those, I'll draw each triangle attached to the center in a way that you can see the way, just knowing the dimensions of one triangle, 3, 4, 5. When you flip it, you get this sort of cross shape here, this traditional shape seen all around in designs. So that is the 12-point circle using one shaped triangle, the 3, 4, 5 right triangle. It works for this triangle because the radius, this circle, because the radius is 5. So it's a nicely designed problem. It has a lot of different ideas here, but you certainly need to be familiar with how to code a circle. X squared plus y squared equals r squared. And you have to be familiar with a line. The blue line is in standard form. 3y minus 4x equals 25. So make sure you have that knowledge for the SAT exam. The next question is another one that uses the Pythagorean theorem. It's, what is the length of the line from the center of circle A to the tangent of circle B, which is inside circle C? So this is kind of hard to see. So again, I'll annotate it with a thick line in, how about red, because it's drawn in red. Well, circle A is the small circle here, x plus 1 y, which means that this is circle A. It's the purple circle on the left with radius 2. And we're going to go from the center of that hub. Think of like a bicycle when there's like the gears in the front and the set of gears in the back. So that would be the center of circles B and C. They're concentric, but one's larger. So we want to do the tangent from the center to this tangent line here. So it's this red line. So that's the point of tangency. And tangent lines form right angles to the center of a circle. So I'm going to place a little right angle square here on the corner. That's 90 degrees. So that's from your teachings in geometry. Anytime you put a tangent line onto a circle, It's 90 degrees to the center point of the circle. So right away, we know that, hold on, if you're building for the circle equation, x plus 1 means the center is at negative 1, 0, and the radius is 2, because this is the square root of 4. For circle B, again, this is graphing circles, x minus 9 means the center is at 9, 0, with a radius of 3. Finally, for circle C, the center is at 9, 0, and the radius is 5. So I'm just going to write those facts here on the right side, just quickly, negative 1, 0, and r equals 2. For the second circle, 9, 0, and the radius is 3. And finally, 9, 0, and the radius is 5. All right, so since the distance between this center and this center can be counted, the boxes, that's 10 units across. So between here and here, I can write the value 10. That's 10 units, because we're going from negative 1 up to 9, like so. Additionally, the radius of the circle here, well, that's circle B. And we know that r is 3. So this side of the right triangle is 3. I know there's a lot of draft lines or design lines in this design, but the tangent line from the center to here would follow the Pythagorean theorem. That'd be this distance here, d. So we can use the Pythagorean theorem. It's this upside down right triangle between this first hub over here and this hub over here. That's the line from here to here. It looks like what the artist did, or the engineer, was, see how circle C is 5 units? So let me get my arrow here. This radius is 2. So if we increase the radius from here 2 units, we get like the chain distance between circles A and C. If you know what I'm talking about, like a bicycle chain that goes around the outside of the bicycle cogs. So in calculating this distance d, notice that it's the same as this distance here, this parallel. So that's just a technical note, because we could space out another 2 units. So it looks like we're really finding this distance, which is another way of saying the distance between this circle and the larger circle, because the radius is 2 more, and this is a radius of 2. So now let's find distance d, which is this distance spanning from here to here, or from here to here. So using the Pythagorean theorem, once again, we have a squared plus b squared equals c squared. So now we have 3 squared plus d squared, plus d, stylus pen is acting up again, plus d squared equals 10 squared. So 9 plus d squared is 100, and d squared is 91. So d is the square root of 91, and the correct answer is A. So what was in this design? They don't draw the right triangle for you, but you have to figure that out from yourself, from your knowledge of geometry. The fact is that tangent lines, it is a tangent line, and they're 90 degrees to the center of a circle. So you needed to know that fact from geometry, and you needed to be familiar with the circle equation and draw the triangle yourself. So that's another example of an advanced problem in geometry on the SAT. Please again use the formula sheet to, when you're working with the coordinate plane, be familiar with the shapes and formulas to help you. But please remember the Pythagorean theorem, which is, of course, very useful with finding distances between points on the gridded plane. The next topic that I'd like to cover is probability and statistics problems. And again, this is about 10 to 15% of all 58 questions on the SAT. Most of these problems test your ability to solve for mean, median, and mode, the mean being the statistical average. Here's an example. Keiko has taken 5 science tests, and she's earned the following grades: 75, 85, 90, 85, and 92. How many more points does Keiko need on the next 2 exams to raise her average to an 88? So most students solve this problem with this method on the right. So I'm going to put that in a blue box. That's how most students solve it. They calculate the number of points that, oh, wait. Sorry, it's not written on the right. The alternate method is all down below. But most students solve it by adding up her points, which would be all of her points all together, which should be 75 plus 85. That's 160. You can add up any way you want. Plus, well, 85 plus 95 is 175. Sorry, 90 plus 85 is 175, plus 92. And that's equal to 335 plus 92. And that's equal to 435, 427. Okay, so far she has 427 points. But she's also going to take 2 more exams. So 427 plus 2x. We take all those points and divide by 7. She wants to have an 88 average. So here's the average formula for Miss Keiko. And that's her points so far, 427, plus the 2 next tests. And divide that by 7. So once you set up the formula for average, that's all of her points altogether divided by 7 tests now, because she's taken 2 more, equals 88. Well, the opposite of dividing by 7 is multiplying by 7. So what we need to do is we need to multiply both sides by 7. And then we get 427 plus 2x equals 88 times 7. Which is 616 points. Next, subtract 427 from both sides. And we get that 2x, or both of the exams, equals 189. So on average, she could get, if we divide by 2, that would be the average that she has to get. But the total number of points for the 2 exams is there. We would stop there at that point. That's the number of points that she needs. The correct answer is 189. An alternate method that might be easier for some students, and it'll help you understand statistics, is let's pretend that, like a robot, every time Keiko takes a test, she gets an 88. Then since there's no variation to her numbers, no deviation, no variance, then, well, all the tests are 88s. So we're going to compare her actual performance to the average 88. So on her first test, she got a 75. So I'm going to write that as 13 points less than the average. On her second test, she got an 85. So that's 3 points less than her average goal. Then she got a 90. So that was a good day for her, because a 90 is better than her average of an 88. On the next test, she got another 85. And then on her last test, she got a 92. So if you look at her average, I'm just going to highlight these and color the good days. You can see that she had 2 good days where she was above average. And she had 3 test days when she was below her average goal so far. So I will just bubble those in red. So notice that the negative ones, she's below her average goal all for each of those tests. But then the 90, 92 were above. So one of the shortcuts in statistics is, Well, let's see how many points she's off from her average. She was 13 below on her first test, then another 3. She's 16 below. And then that fourth test, another 3. So that's minus 19 points. But she had 2 tests where she was above her average goal, those 6 points. So we have negative 19 plus 6. She's really 13 points below her 88 average. So that means that when she takes her next 2 tests, if she wants to earn enough points to get her average, she wants these tests to be 88s plus 13 points distributed however. So that would be 88 plus 13, or 189 points altogether, would rebalance it so that on the average, it's 88. It could be 100 on one test and 89 on the other test. It could be a 99 on one test and a 90 on the other test, or it could be a 98 on one test and then a 91 on the other test. But no matter what those last 2 scores are, make sure that those are 2 test scores. She's got to do some pretty well in these tests. She has to have 2 numbers that add up to 189. So that's the amount of points she needs. You still get the same answer. But it's nice to think of the average as like if no child, no human really performs like a robot over the whole semester. We have our ups and downs, but you can see the Keiko really needs to really be like, okay, if I want to do well in this class, I better start sitting with my books and I better start reviewing everything and trying to get better. She's got to get 2 high grades on those last tests. In fact, a total of 189 points out of 200. The charts and graphs problems are often done very well by students who do math because they have them in science class, they have them in social studies and history, they have them in other classes as well, charts and graphs. Even reading a book, sometimes they have a chart and graph that's relevant to the characters, relevant to the topic at hand. So these types of questions will ask you to complete information from a given data and answer word problems. So there'll be line graphs and pie charts and charts and percentages and frequency tables. But the one that I'd like to go over is coming back in popularity as the two-way table. So here we have 2 measurements that are being compared, cross-compared, and totals. And here we have a survey, and it was given to both girls and boys. And the survey asked if you this semester have an English class, a math class, or a science class, and then the totals. And you can see that the chart is not complete, but it's a 2-way table. So let's try and complete the chart by going across the row. So this means that for girls, 20 of the girls go to English class, 13 go to math class, and then blank go to science class for a total of 50. Now, what it should say is that everyone goes to just one class during this class. It should probably like period 1 during the day. Okay, so then let's figure out what girls should belong in the science room during this class time. So 50 is the total, minus 20 is 30, minus 13 gives us 17. So that means that highlighted in red, that we would type in 17 girls belong in science class during this class time. For the boys, it's a little more different. They don't tell us how many boys were in the survey. And so how are we supposed to fill out the rows for the boys? Well, it's cross-hatched. So it's also, we have the subtotals by class that they're in. So in the English class, it's really large. There are 38 students packed into that room. 20 of the students are girls. By subtraction, 38 minus 20 means there are 18 boys. Filling out that cell, 18 boys belong in English class at that time. Here for the math classes, 13 plus 15 is given, so there are a total of 28 students who are enrolled in math class. For the science students, the girls we figured out is 17 from the row information. 40 minus 17 is 23. So there are 23 boys in science class. So now we can go back to the boys row and add those numbers together. And we get 18 plus 15 is 33, 43, 53, 56. So 56 boys were surveyed. And now, looking at these margin totals, we should see that if we add these totals here, it should be the same as adding this column here. So in this corner cell, we should get the total population. 50 plus 56 is 106. And if we entered all the data in the cells correctly, adding these three numbers should be 106. And it is, because 38 plus 28 is 66, plus 40 is 106 total in the survey. Okay, so 106 total students. So that number in the corner is the grand total of these 6 cells. If you're a girl, you're in English, math, and science at that time, or if you're a boy, you're in English, math, and science. Now the table is completed. That's a two-way table. There's 2 different questions posed, gender and class at that time. Complete the two-way table using the information given. How many boys are in science class? So then make sure you go to the correct cell. So I'll go back to my highlighter. And then you want the boys. So you have to go to the row for boys, and you have to go to the column for science. And in that cell, we have the number 23. The correct answer is A. For question 17, if you picked out a random boy, what's the probability he would be in English class? Well, the total population of boys is 56, and the number of students that are in English class is 18. So it looks like it might be B, but the writer messed up. But it's not, because those are both even numbers. So make sure you divide by 2, and you should get 9 out of 29. It's correct. No, that's not correct. 9 out of 28. See? 9 out of 28, it's E. A is trick answer. So both A and B are trick answers. It's choice E. Question 18, if you picked out a random student, what is the probability she would be in a science class? So now for the, sorry, I just wanted to erase the arrows. I don't want to erase that. So she must be in science class. So here we are using the total population. So be careful, because we're picking out a random student from all of the students. So that's the denominator. And then she must be a girl from science class. So from these 6 cells, we're interested in girls that attend science at that time. So the correct answer is A. In this conditional, in this probability, 17 out of 106. One technical note, when you have a subpopulation, boys only, and it's boys that are in science class, you can set it up as, there's more than one way to set up these conditional fractions, but it's from the population of boys only in this one, and the population that is an English boy, given that it's a boy. So that's how you work a two-way table. The ones that are most challenging for students seem to be these ones, like question number 17. Just make sure that you have the right denominator, 56 for boys, and it was 18 out of 56, which reduces properly to 9 out of 28. There are a few other topics on the SAT, but again, at most, there's 1 or 2 problems testing these skills. So as you do your final review for the SAT, it's good to go over the lessons on angle relationships, circle relationships, which means like tangents, secants, chords, diameters, inscribed angles, and central angles. The other topics from Algebra 2 are exponent rules and logarithms, like logs with a certain base, the law of sines, the law of cosines, complex numbers, which are based on the idea of the square root of -1 is I, exponential equations, and higher order polynomials, such as cubics or x to the 4th power equations or x to the 5th power. Function compositions, where you follow one function rule, take that mapped result, and take that number, bring it to a second function rule. That's a function composition. Statistics of the normal curve, the bell curve, which has to do with variation of data and variance and standard deviation. And finally, scatter plots, and if the plots seem to form a best line fit. And that line can be a straight line or quadratic on the SAT. Let's finish up with one more problem from angle relationships. And here I wrote this problem for the SAT class at Chang Learning. It says, well, what is the measure of angle ABC minus ABI? Well, angle ABC has to be found based on the vertices of the picture that I created. So ABC is this inside angle inside this irregular octagon. And each angle measure is expressed as an algebraic expression going around the 8 vertices. ABI is the external angle to the shape. So if we approach from point I, it's this angle measure here. Then if we're part of this octagon shape, these are the 8 angles in the set. Well, the first thing you have to know from angle measure is that there is a sum of the angles inside a polygon. The way you do that is you go to one corner and you just draw a chord to each of the other vertices. So when we do this for the octagon, you can see that AB is already drawn. These two walls are already connected, but B has to meet point H, point G, point F, point E, and point D. So just go around the circle as if there were 8 people working at a table, and you were saying hello to each one going around the table. Okay, just draw each edge. Then you can see that the entire shape, the entire space, is split into 6 triangles. 1, 2, 3, 4, 5, 6, even though there are 8 sides. Each triangle has a measure of 180 degrees inside. So the total area of the octagon is 1,080 degrees. Now this confuses some students, but just think this angle is unchanged. Angle D is just now shared between triangles 1 and 2. But together, when you sum them, you're just summing these angles between the triangles. And similarly, angle D is split between triangles 2 and 3. Angle F is shared. Angle G shared between 2 triangles. Angle H, angle A is unchanged, but angle B is now in 6 units. Okay, but all together, since each individual is triangle 180, when you sum them, no matter how you sum them up, it'll be 1,080 degrees. So the next step is to take each algebraic expression and as quickly as possible add them together. Each corner has an x in it, so that's 8x, right? It's just x, it's not 2x or 3x or 5x or 17x, just 8, it's just x. That's 8x. Then I would probably go around and just add the positives together, which is what I did here. 15, 25, 35, 45, 55, 65, 75, plus 25 is 100 positive units. Then go back to point B and add the negative units as you encounter them. Here, negative 15 minus another 5, and done. So that's minus 20. So we get 8x plus 100 minus 20 is 1080. 100 minus 20 is 80. Subtract 80 from both sides, and 8x is 1,000. Divide both sides by 2. 4x is 500. Divide by 2 again. 2x is 250, which means divide by 2 again, x is 125. Now we can find our angles now that we know what x is. X is 125 degrees. So in place here, inside the octagon, it's 140 degrees. And the external angle, if we were to exit along this path to point I, this is 40 degrees. The question was, what's the difference in angles? Well, here at this juncture, 140 minus 40 is choice C, 100 degrees of angle measure, the end. So that was my design for an algebra, an algebra problem with angle relationships. So to recap, as we finish up here, make sure that you go over the special topics, but remember that total that could be 10 to 15% of the exam as well. In the section 3 math section, no calculators are allowed, and you'll have 25 minutes to complete 20 questions. In section 4 math, you should have a charged and ready to go scientific calculator like the TI-84 Plus or the Casio, so that you can graph as well as compute using SOHCAHTOA, any exponential problems, and also evaluate the polygons in algebra. You'll have 55 total minutes to complete 38 questions. A few test-taking strategies. Prepare in an organized way. Remember to focus on algebra and geometry, the coordinate plane, charts and graphs, and statistics, lessons from grade 9 and 10. Be comfortable with SAT level of questions by exposure to as many practice questions as possible. Work on your own time management and be sure to complete the easy to mid-level questions first. Remember when I started this presentation, there are about 37 questions that are considered easy to mid-level. So if you focus on first, then with your remaining time, work on the more difficult ones. You'll find that you're less frustrated and you're using your time more wisely. Some multiple choice questions can be solved by plug-in of the answer choices. So if you're doing a multiple choice question, look at those 4 answers and try throwing those numbers into the formulas that are given in the problem presented. Some multiple choice questions can be simplified by plugging in a value for the variable. So sometimes it's not given, or the answer is given as an algebraic expression. So you just choose a number, plug in 1, 2, 3, 4, and 5 for the variables that are given. Just make sure that as you go through your work procedure, that you keep those variables consistent and don't change them as you're doing your computations. Estimate the answer to save procedural time on questions. Study and memorize the formulas and solution methods before the exam. And look for SAT shortcuts. So thank you for watching this final review on some tips and tricks for handling sections on the SAT exam. Again, it's an honor to be your SAT mathematics teacher and to write these lessons for you to improve your mathematics skills. And thank you for being here as a student at Chang Learning, and good luck on your next SAT exam practice.